Hello everyone, I am Sakshi Vani, a second year BTech student in Data Science and Cybersecurity Department at GH Raisoni College of Engineering and Management, Pune. Myself and my team members, Tanushree Altiwal, Tehseen Sheikh, and Samarth Dudbate, under the mentorship of Professor Rupali Parte ma'am and the guidance of our HOD, Dr. Deepika Azarkar ma'am, completed a project on the title Real-Time Sign Detection System. So let me introduce our project poster, and after that we will discuss the programming steps in details. So the main aim of our project is to bridge the communication gap between the deaf and hard of hearing community and with the general population. It just translates the sign language gestures into written language in real time. So now we will discuss the programming steps and the implementation of the code. Moving further, we have created our own dataset which consists of various hand gestures of various ASL signs, and the dataset includes the samples of each alphabet letter, that is from A to Z, and also the digits, that is from 0 to 9. And it was labeled manually to train the machine learning model using the CNN algorithm, which is Convolutional Neural Network, which is used for training this detection model. So it is very useful in image classification tasks, as well as it is widely used in the computer vision applications. So let's move further of how we have implemented this project. So in this sign image 48 cross 48, we have made our data set where we have classes, that means for 0 we have this many images. I think we have taken about 120 to 150 of images each. I can show you here, for example, this one. So this is the ASL sign for the 0, that is the digit 0. And moving further, we have then split the data set into two categories, that is the training and the validation set. So we have split the data set by using the split.py Python script. And here you can see we have imported the split folders Python library, which provides a very simple way to split a data set into separate training and the validation sets. So it automatically split a folder of images into separate folders for each of these sets. So we have split the dataset in the ratio 0.8, that is 80% for training, and 0.2, which means 20% for testing. After splitting the dataset, we have trained our model using the Google Colab and the notebook. So this is the code for it. As you can see, we have imported various Python libraries, which includes Keras, TensorFlow, and here you can see the Keras modules, various modules we have imported. And I will show you the important code of it, that is the CNL algorithm. I will just explain in shortly. So let's break down this code. So this model initialization is, it is a sequential model, which is a linear stack of layers. Then you can see here it is a convolutional layer. That means these are the backbones of the CNNs. That means they apply a set of filters to the input data to extract the relevant features of the images. Then here you can see the second part of the code, that is this line you can see here. It adds a convolutional layer to the model, which is the first convolutional layer. It consists of 256, you can say 256 filters with a kernel size of about 3 by 3 using the ReLU activation function. And the input shape here you can see is 48 cross 48, which is a parameter. Then you can see this max pooling 2D, which is a layer which downsamples the input representation, means it reduces its dimensionality, and it is with 2 by 2 window size is applied after each convolutional layer. You can see here. So the first here it is convolutional layer, then we have used the max pooling layer. Here you can see the convolutional layer and then the max pooling layer. So we have used 4 convolutional and 4 max pool layers, and then we have used the dropout layers, which are used to prevent the overfitting by just randomly selecting the fraction of input units to 0 during the training. So here you can see the dropout 0.4, which means that 40% of the input units, it will be dropped randomly during the training. And then here you can see we have just written here model.add flatten. That means it is a layer which flattens the 2D feature maps into a 1D vector, preparing the data for the input into a fully connected layers. So after that we have fully connected layers, which means it is the
you can say the brain of the CNN, fully connected layers, because they perform classification based on the features that are extracted by this convolutional layers. And after that, you can see here the output layer, which is the final layer of the network, and it predicts the class probabilities for each input sample. We have also added the softmax activation here. This softmax activation, it converts the raw scores that are generated by the model into the probabilities, making it very suitable for multi-class classification problems. So this is how the CNN algorithm is worked here. And this is the whole code for it. Then we have trained the model. We have seen its accuracy by using this tensor board graphs and all. We have used the epoch 100 for that. And we have got the accuracy of 0.98 for, and validation accuracy is 0.99. And we have just saved our data, the architecture, the model architecture and its weight into a JSON file and .h5 extension file. So after training the model, we have used the main Python script, that is the real-time sign detection.py. This Python script is using the OpenCV to capture the video from a webcam to perform the real-time hand gesture recognition. It's also using the Keras models and the library NumPy. And after that, we have added our JSON file and the h.h5 file, that is for the model architecture and its weight. After that, here you can see the main code, or here first we have defined one list which consists of 0 to 9 alphabet, the 0 to 9 digits and A to Z alphabets, and one blank label. And after this, here you can see the loop, which is the main part of the script, which enters an infinite loop where it continuously captures the frames from the webcam. And that's it. So let's run this file. This is the sign A, this is the sign B, this is C. You can see for all the words here, the here you can see the alphabet that is shown, that is D, and in front of it, it is the probability of it, that is 99.75, 99.9, 100. Okay, so then we can just see for L, this is L. Okay, and then I can say for O. Okay, this is K. Sorry, this is K. Yep. And this is how you can show your hand gestures to it. So that's it. B, Y, A. Bye bye.